Welcome back to our alien tour of Earth's history, where we reconstruct what prehistoric Earth might have looked like over millions and billions of years. For those just tuning in, our premise is this. Imagine that alien scientists are visiting Earth at various stages in its development. What do they see? In part 1, our alien voyagers covered a big chunk of Earth's timeline, 4.2 billion years of it. They saw the formation of the planet, a hot, molten, swirling mess, its eventual cooling, the emergence of the first organisms, and the great oxidation event that gave Earth its modern atmosphere. They swung by in the Cambrian period to witness an explosion of species diversity across our planet, and landed in the Devonian period some 350 million years ago. In part 2, our alien scientists came back to take a more in-depth look at some of the animals that roamed our then flourishing tropical Earth some 150 million years ago. Supersaurus gave them a scare, while the furry little Taenia labis caught their eye with its playful and social disposition, while Archaeopteryx circled above. Today, they revisit Earth, some 84 million years later, totally oblivious to the changes that have occurred on this now dramatically different planet. For the last tens of millions of years, every time our alien friends flew over Earth, they'd seen a lush, green world run by the likes of Ceratosaurus, Spirosaurus, and Eoraptor. Let's imagine our alien explorers decide to descend and collect samples of this incredible world on a certain day 66 million years ago. But first, they need to make a pit stop. They're running low on helium-3 and swing by Jupiter to fuel up. Without this source of power, their ship won't be able to take off again once they land on Earth. Tomorrow, they agree, they'll come back. When they return the next day, they double-check their GPS, or galactic positioning system. They must have made a mistake. There is no way the fireball covered in soot they're looking at is the same thriving planet they flew over yesterday. Our alien friends are flabbergasted. What could have happened to cause such utter devastation? The Earth they came back to is covered in raging wildfires, tsunamis up to 1 kilometer high, and immense, inescapable death. A new reality has set in, one that would consume the planet for the next couple of decades. To find out what happened, let's jump forward in time to see what our human scientists have to say on the matter. In the 1980s, 2 human scientists made a huge discovery. They detected the presence of a chemical element called iridium in the geological record, exactly at a point in time dinosaurs disappeared from the fossil record, also known as the Cretaceous-Paleogene or KPG boundary. Not only that, but this specific iridium ring has consistently been found at the KPG boundary in samples taken from around the world. It seemed like something deposited an immense amount of iridium all over the Earth's crust at the same time that dinosaurs went extinct. The curious thing is that iridium is usually pretty hard to come by on Earth, and these rock layers at the KPG boundary contained 200 times the amount of iridium we would normally expect to find. Can you guess where iridium is abundant? Asteroids. But if such a catastrophically large asteroid did crash down to Earth, it would leave behind a crater that would be pretty hard to miss. Well, just a few years later, the human scientists found that too. Known today as the Chicxulub crater, it lies off the coast of the Yucatan Peninsula in Mexico and spans a whopping 200 kilometers. After some testing, researchers confirmed the age of the crater as being about 66 million years old, lining it up exactly with the iridium in the KPG boundary and the disappearance of dinosaurs from the fossil record. Another core piece of evidence that supports the asteroid theory is something called tektites. They've been found in abundance in several places, with one of the most astounding discoveries coming from North Dakota, USA. Researchers found a fossilized mass grave with fish, burned tree trunks, conifer branches, mammals, mosasaur bones, insects, and the partial carcass of a triceratops, all frozen in time together, along the KPG boundary. Scientists had never seen such a collection of diverse organisms in different life stages who died at the same time. And in and among all the fossils were countless tektites and microtektites. The leading theory is that they are actually pieces of molten earth crust that were shot up into the sky on impact. High in the atmosphere, they cooled into natural glass and then rained back down onto the earth in a glass shower at speeds of 160 to 300 kilometers per hour. And remember, North Dakota is 3,000 kilometers away from the impact. So let's gather this evidence together and paint a picture for our alien travelers of what could have happened to Earth while they were filling up on gas. As our extraterrestrial explorers turned their back to Earth, they might have noticed an asteroid accelerating towards the planet, getting brighter and bigger against the blackness of space. About 10 to 15 kilometers wide and traveling at 72,000 kilometers per hour, it makes contact just off the shore of the Yucatan Peninsula of modern-day Mexico. This releases an insane amount of energy, all at one go, the equivalent of detonating billions of nuclear weapons at the same time. This was an earthquake felt around the globe. There's no way it went unnoticed, even by animals on the other side of the planet in modern-day Indonesia. At the impact site, the thermal radiation burns everything within a 1,500 kilometer radius. The force of the impact from the asteroid makes the Earth's crust go molten and splash up like water after a pebble has been dropped in, leaving behind a monstrous crater 25 kilometers deep and 100 kilometers wide. This causes a chain reaction of enormous tidal waves, hundreds of meters high, as the ocean is pushed back from the immense force. Meanwhile, trillions of metric tons of debris, about 60 times the mass of the asteroid, explodes up into the atmosphere. Some of this debris are chunks of molten earth crust, which, high in the atmosphere, coalesce into tektites. And inevitably, what goes up must come down. For about 15 minutes following the initial impact, Earth is covered in a torrential storm of fire rain. Falling debris heats out to hundreds of degrees Celsius as it passes through Earth's atmosphere. This sets the world on fire, burning down 70% of its forests. Vaporized material that doesn't rain down as debris, such as silica dust from rocks, stays suspended in the atmosphere, along with unbelievable amounts of soot and carbon dioxide rising from the wildfires. If you're breathing a sigh of relief for our Indonesian dinosaur friends on the other side of the planet, don't. Like with most things, it's never the actual impact that leads to the most devastation. It's the aftermath. The buildup of gases and particle debris in the atmosphere blocks out the sun, plunging the planet into an impact winter that will last at least 15 years. With no sun, plants are unable to photosynthesize, and both terrestrial and marine food chains collapse. Earth is a totally apocalyptic version of its former glory. No wonder our alien travelers had to check their GPS. The impact this would have had on animals would have been devastating. 75% of all species are wiped out forever, making this one of the largest mass extinction events in Earth's history, second only to the Permian extinction we covered in Part 2. All the animals that exist on Earth today are descendants of the survivors of this apocalypse. Others were not so lucky. Being large is a disadvantage in an apocalypse. You need lots of food, lots of space, and lots of resources. All terrestrial and marine dinosaurs suffered greatly and eventually died out as a result. A small slither of avian dinosaurs had better luck and managed to slink through the evolutionary bottleneck into the Paleogene period. They still roam the Earth today through their direct descendants, birds. When we think of birds, we think beaks. But back in the Cretaceous days, birds came in all kinds of different, wonderful variations that we've never seen with our own eyes. Some had beaks, some didn't. Some had teeth, some didn't. While it would be foolish to credit a single trait for the survival of an entire family line, it sure seems that if you were a bird 66 million years ago, having a beak stacked the odds in your favor. We think that beaked birds had an advantage as they could dig out seeds from the ground when no other food source was available. Toward the end of the Cretaceous, beaked birds were already eating a more varied diet than their non-beaked cousins. This would have been a huge advantage when rations were scarce. After all, being a picky eater in an apocalypse isn't really a good idea. Having enough force in the gizzard to crush tough fruits and seeds, and enough flight stamina to gather food over large distances also helped with survival. Some species of mammal also managed to push through. It is thought that only mammals smaller than 10 centimeters survived, as they could hide underground where they were somewhat insulated from the lower global temperatures. Being small also meant they needed less food to survive. The platypus is an example of a mammal that coexisted with dinosaurs, survived the KPG extinction, and is still around to this day. Turtles also fared surprisingly well, although it isn't understood why. About 80% of the known turtle species made it through the KPG extinction, as did crocodiles. While we can't be 100% sure why, some ideas are that crocodiles, like beaked birds, have highly diverse diets, and they can survive without food for more than a year, thanks to their excellent energy conservation abilities. Following the catastrophe, repopulation seems to have happened very fast. If our alien scientists were to fly over Earth just 30,000 years later, they'd already see flourishing new ecosystems rising from the ashes in some parts of the planet. Maybe it was for the best that our alien crew was low on helium-3 and didn't have to witness the apocalypse firsthand. Revising our version of events, our alien friends are not convinced this is the full story. They are good scientists and better skeptics. Just because the evidence paints one picture doesn't mean it can't also paint another. Indeed, that is the exact conundrum we, Homo sapiens, find ourselves in now. While many human scientists hold firmly to the asteroid theory, others think differently. Let's rewind the tape and re-examine the evidence. The initial clue that started all this asteroid business is that pesky element iridium. While it is present in asteroids, it is also present in another key place, the Earth's core. This gives weight to another popular theory, that crazy strong volcanic eruptions could be the culprit behind the mass extinction instead. In this scenario, the world would still be covered by a blanket of smoke, soot, and debris, tektites would rain down, and the sun would be blocked out for years, causing a super long winter and total ecosystem collapse. And our iridium would still make it into the geological record. The effects are largely the same. The only difference is the root cause. So, is an asteroid or volcanoes to blame? There is evidence showing massive volcanic activity during the late Cretaceous, before the supposed asteroid hit. Researchers say that the presence of flood basalt corresponds with 3 out of the 5 mass extinctions, including the one that killed the dinosaurs. Flood basalts are left behind when massive areas of land are rapidly flooded with lava. They leave behind step-shaped igneous rock formations called traps. The Great Permian extinction our alien friends witnessed in the last video was triggered by volcanic eruptions that would later form the Siberian Trap. Some scientists think the same thing happened to the dinosaurs and left its fingerprints in the Deccan Traps in modern-day West India. Data shows this region was highly active at the time of the dinosaur extinction. A violent eruption would have had far-reaching global effects, filling the atmosphere with dust, toxic sulfur and carbon dioxide gases, causing a wipeout in a similar way to the asteroid theory. Indeed, supercomputer simulations have shown that there is an incredibly strong correlation between flood basalt events and mass extinction events, much higher than pure chance. However, some scientists don't think it is an either-or situation. A growing body of research is trying to reconcile a both-and version of events, suggesting that the impact of the asteroid and the subsequent earthquakes potentiated the ongoing volcanic activity, taking it over the lethal threshold and into mass extinction territory. But the extent to which each event played a role is still up for debate. I hope this exploration of possible theories is enough to satisfy our alien scientists. By now, they've seen Earth in enough of its forms to know that if there is one thing they can rely on, it's transience. Earth won't be a ball of fiery rain and eternal winter forever. It's just a matter of time before life springs up again. Who knows what they'll see on their next flyby?